Hey, hi, hello. Welcome to homework video number 17. I feel like I haven't made one of these in a while, so it's just great to be back. We'll do the left-hand side of these and one on the bottom, and then the back as well. So starting with this one, it says solve the equations below using the unit circle. So make sure you have your handy unit circle next to you. There's one attached on Google Classroom. It says find x when x is between 0 and 2 pi for the following. So this means for one rotation around the unit circle. Okay, so let's look at this question first. I always like to write these questions in words before I solve them. This says cosine x is equal to square root of 3 over 2. What this is asking me is what angle measure has an x value, because remember the way we always write these, cosine is always your x value, sine is always your y value. So what angle measure has an x value of root 3 over 2? Okay, so let's answer that question looking at my unit circle. If I'm looking at my unit circle, I'm looking for x values of root 3 over 2. So as I'm going around my circle, boom, I see an x value of root 3 over 2. So I know that the angle measure is either 30 degrees or pi over 6. So 30 degrees, pi over 6, x equals, okay? And then looking again, we always want to double check if there are multiple answers. So here's an x value of positive 3 over 2. I'm going to go around, looking at all of my x values until, boom, again, guess that's my catchphrase for today, I hit another x value of square root of 3 over 2. Okay, that matches the angle measures of 330 and 11 pi over 6. So here I've got 330 and 11 pi over 6. Okay, so these are my two values for x because there are two places where my x value is root 3 over 2 on the unit circle. Okay, moving on to this next question, I have sine of theta equals negative 1/2. Let's rewrite this as a question. So what this is asking me is what angle measures have a y value of negative 1/2. Because remember, sine is our y values. So I'm going to look here and I'm going to look for y values of negative 1/2. I'm going to look around my unit circle. Looking for, boom, y value of negative 1/2. Okay, so I've got 210, 7 pi over 6. 7 pi over 6, because that is a y value, yep. And then around again, looking for y values of negative 1/2. I've got one more y value at negative 1/2. The angle measure there is 330 and 11 pi over 6. So 330 and 11 pi over 6. Okay? Now we're going to do essentially the same thing down here, but we've got an interesting domain restriction. This says find x when x is between 0 and 720 for the following. So 720 we can break down into 360 plus 360. So that is 2 rotations around the unit circle. Okay, so we have to find all places that what angle measures equal these x or y values going around the circle twice. So let's do cosine x of negative 1 first. That means I'm looking for all negative ones that are x values, because cosine means x values. So I'm going to look at my unit circle here. Let me grab another color pen so we can do this. Purple is going to be 0 to 360 in my rotations. Oh, you can't see that. Okay, and then in pencil is going to be 361 to 720. Okay, so we are looking for, like we said before, x values of negative 1. So let's go our first rotation, finding x values of negative 1. So I'm looking. I've got an x value of negative 1 here. Okay, and then looking. That seems to be my only x value of negative 1. Okay, it's at 180 degrees. So I'm going to write 180 degrees here. Okay. Now that was only one rotation around the circle. I need to do a second rotation around the circle. Okay, so that was 360. Now I'm in my second rotation. I end up at this same spot again. So I need to do 360 plus that 180. So 360, calculate, plus 180 gives me 540. So the other location would be x equals 540. So in my first rotation around the circle, there was 1 point, or 1 angle measure that had an x value of -1. In my second rotation around the circle, that same location, but a different degree measure because we're on our second rotation. Okay? I'm going to do one more of these with you, and I'm going to let you figure out those two on your own. Okay? So this next one is sine x equals -1, or sorry, +1, excuse me, sine x equals +1. So actually, let's do this one. Let's do this one instead, changing it up. Cosine x equals 0. So I'm looking for x values of 0. Okay, again, purple is my once around rotation, and then in pencil will be my second rotation. So around my once around rotation, I'm looking for x values of 0. Okay, found one here. Keep rotating, rotating, rotating. I found another one here. Okay, so that means 90 and 270 have x values of 0. So x equals 90 and 270 for my first rotation. Okay, now my second rotation, I've got 360 because I'm starting at my second rotation. When I rotate, again, I hit this point and I hit this one down here. So I need to do 360 plus 90 and 360 plus 270. Okay. When I add those together, I'm going to get x is equal to 450 and x is equal to 630. Okay. So in one rotation around the circle, I have 2 places or 2 angle measures that have an x value of 0. In my second rotation around the circle, I have another 2 places where my x value is equal to 0. Okay, so you're essentially doing the same thing, you've just got to rotate around the circle twice. I'll let you finish up these ones and the right-hand side. Next one we're going to do is a review problem for sequences and series. And I've got a blank sheet of paper to do this one on because I didn't leave you a ton of space here, and I'm sorry for that. So I'm going to do mine on a separate sheet of paper, okay? It says, in an arithmetic sequence, U10 equals 8, U11 equals 6.5. So remember, arithmetic means we're changing by a constant of addition or subtraction. And this means our 10th term is 8, and our 11th term is 6.5. So I'm going to draw that out here. I've got my 10th term is 8, my 11th term is 6.5. Okay, in this arithmetic sequence. So let's see what the first question asks us. It says, write down the value of the common difference. Okay, this is the change value. It's always going to be the term minus the term before. So a term, UN, minus the term before. Okay, so let's look at that here. I've got 6.5, that's my term. I guess I should write these as like this is question A. 6.5 minus the term before. So 6.5 minus 8, that's going to give me negative 1.5. So that is my common difference. I know that this is changing by minus 1.5 each time. You can always double check that. Okay, if I've got 8 minus 1.5, it gets me to 6.5. So when I use this common difference, I get to the correct next term. Okay, so I know that my common difference is negative 1.5. Question B says, find the first term. So find the first term in the sequence. Well, I've got terms 10 and 11. That means I need to go all the way back to 9, 8, 7, 6, 5, 4, 3, 2, 1. Huh, just enough space. Way to go, me. Okay, so going to the right, I did minus 1.5. If I'm going in the opposite direction, I need to do the inverse operation. So going to the left, I'm going to do plus 1.5. So I'm going to do 8 plus 1.5. So 8 plus 1.5, that gives me 9.5. Okay? Because if I did 9.5 minus 1.5, it would get me back to my value of 8. My common difference would stay the same. But because we're going in the opposite direction, we have to do the inverse operation. Okay, so I'm just going to continue adding 1.5 each time. If I continue adding 1.5 each time, I'm going to get to 11, 12.5, 14, 15.5. Oh, sorry, I thought I was going to sneeze. 17, 18.5, 20, 21.5. And I've gotten all the way back to my first term by adding the common difference back each time. So my first term here, u1, is equal to 21.5. Okay, very last one says find the sum of the first 50 terms of the sequence. So this is part C, find the sum of the first 50 terms of the sequence. No, not the lights. Oh, there it goes. Okay, you're going to need your formula booklet for this, and I will post this on Google Classroom as well. Under the section that says algebra, it has all your sequences and series formulas. We know that this is an arithmetic sequence from the beginning. It told us in an arithmetic sequence, and we're looking for the sum. So an arithmetic sequence looking for the sum. So sum of n terms in an arithmetic sequence, we're using this formula here. I'm going to write that down. So n over 2, parentheses 2u1 plus n minus 1 times d. Okay, quick reminder of what all these variables mean. N is the term number. U1 is the first term. And D is the common difference. So the numbers that go in those, well, it said the sum of the first 50 terms. So N is equal to 50. U1 is the first term. That's what we just found. The first term is 21.5. And the common difference is what we found before, negative 1.5. Okay. So from there, we're just going to plug in what we know. I know n is equal to 50. So 50 over 2, parentheses 2, times the first term, which is 21.5, plus n, which is 50, minus 1, times the common difference of negative 1.5. From there, I am just going to pop that straight into my calculator, and I'm going to get 50 over 2, parentheses 2, parentheses 21.5, plus parentheses 50 minus 1 times negative 1.5. That's going to give me negative 762.5. So my sum of the first 60 terms is going to be negative 762.5. Okay, very, very similar equation here, or arithmetic sequence here. You just got to be a little bit careful, and here it gives you the third term is 10. It doesn't give you the fourth term, and the fifth term is 16. So be careful about how you set this one up. All right, I think that is everything for the front, so we are going to go ahead and flip over to the back of this, doing a little bit of graphing. Okay, oh, that's the wrong way to zoom out. Let's do it on this brand new one so the purple doesn't show through. Okay, it says graph the parent sine function below, identify the period and the amplitude. Identify the period and the amplitude. Okay, so graphing this goes back to solving using the unit circle, so make sure you have the unit circle with you. Okay, sine, I know is always, this one is sine, right? Yep, sine is always my y values. Okay, so to graph this, I'm just going to pick a few points on my unit circle. So I'm going to start with 0. At 0, my y value is 0, so I'm going to plot the point 0, 0. At pi over 2, my y value, sorry it's hard to see because I've drawn all over it, is 1. So at pi over 2, I'm going to plot 1. At pi, my y value is negative 1. No, excuse me, my y value is 0. Sorry, we're looking at y values. My y value is 0, so I'm going to plot 0 here. At 3 pi over 2, 3 pi over 2, my y value is -1. So I'm going to plot -1 here. And finally at 2 pi, where's 2 pi? Well, 2 pi is a full rotation around the circle, right? So we're right back where we started. My y value is 0. So I'm going to plot 0 here. My function should look, or positive part of my function should look something like this. We know that our functions are repetitive. We know our sine function is repetitive. Okay, so if I wanted to plot the rest of this, I know that this next part of the function should look exactly the same. So I would go down here to -1, 0, +1, 2. If I trace that back in, this 360 degrees looks exactly like this 360 degrees. So remember, our period of our function is when it repeats itself. Because it's a circle, our period is 360 degrees, or 2 pi. Amplitude is the distance from the x-axis to the maximum. So our amplitude here is 1. Or the distance from the x-axis to the minimum. Again, the amplitude is 1. So my amplitude is equal to 1. Okay, you're going to do the same for the cosine function. Please remember that cosine function is x values. Cosine function is x values when you're going through your unit circle. All right, next we are going to do here Math SL cumulative review. This is a pretty tricky problem, so stick with me on this one, but it is on geometric sequences. Remember, geometric has a common ratio, so you're changing by multiplication or division with geometric sequences. And it gives us the first 3 terms. So the first 3 terms of this are, and I'm going to draw it out here. The first 3 terms, so this is term 1, term 2, and term 3, are m minus 1, 6, and m plus 4. Okay? Let's see what's the first thing it asks me. It says write down an expression for the common ratio, or R. Okay? We find the common ratio by dividing the term by the term before it. So un divided by the term before it. So if I'm looking at that, the term would be 6 divided by the term before it would be m minus 1. So 6 over m minus 1 would equal R. The other thing I could set up as a term divided by a term before it, m plus 4 is my third term, divided by the term before it, which is 6. Both of these are acceptable answers for part 1, because both of them are equivalent. Okay, so our common ratio is the term divided by the term before it. Notice we don't have to solve for anything. It just said to write an expression. We don't actually have to solve for anything. Okay, so if I knew the value of m, I could solve for my common ratio here. Okay, next thing it asks us is hence show that m satisfies the equation m squared plus 3m minus 40 equals 0. Okay, remember show that just means do the math. Do the math that proves this equation is true. Okay? Well, theoretically, if these are both equal to r, they should also both be equal to each other. So I could write the expression 6 over m minus 1 is equal to m plus 4 over 6. Okay? If they're both equal to r, they both also have to be equal to each other. Now, this is something that I can solve because I only have one variable here. When I have a single fraction equal to a single fraction, the first thing that I'm going to do is cross multiply. Okay, so I've got 6 times 6 will give me 36. M minus 1 times m minus 4, or m plus 4, excuse me. That's going to need box method to fully multiply that out. So box method would give me m minus 1, m plus 4. M times m is m squared. M times negative 1 is negative m. 4 times m is 4m, and 4 times negative 1 is negative 4. Combine your like terms within the box. That's going to give me m squared plus 3m minus 4 equals, bringing this down, the right-hand side of the equation down, 36. Okay? Well, that doesn't look exactly like the equation it's asked me to make it look like. I need this equation equal to 0. So I'm going to look at this one more time. To make this equal to 0, I can subtract 36 on both sides. Negative 4 minus 36 is negative 40. 3m plus m squared. And now my expression looks exactly like their expression here. Okay, so I just had to set them equal and cross multiply. That'll be part B. Beautiful. 2 more parts left, okay? Part B says find the 2 possible values of m. Find the 2 possible values of m. Well, if you'll notice here, we have an expression or an equation with 3 terms and a highest exponent of 2, which makes it a quadratic, which, oh boy, means that it can be factored. Looking back at our x factor, a times c in the top, so negative 40 in the top, b in the bottom, so 3 in the bottom. We're looking for 2 numbers that multiply to negative 40 and add to 3. Those 2 numbers are going to be 8 and negative 5. So I write my expression as m plus 8, m minus 5. All that is equal to 0. I can break these as to both being equal to 0. Minus 5 equals 0. Subtract 8 on both sides. I get m is equal to negative 8. Add 5 on both sides. M is equal to positive 5. Okay, so those are my 2 possible values for m. Very last question here. We're almost done. Find possible values of r. Okay, well, I know what m is equal to, and way back at the beginning of this problem, which probably seems like ages ago, I found out what r was equal to as well, right? So I'm going to write down what I know. I'm going to write it over here. r equals 6 over m minus 1. That's from part 1 when I was setting up my term divided by the term before. And I know that m is equal to negative 8 and m is equal to 5. So m is equal to negative 8, m is equal to 5. I can plug in each of those values and get a specific value for r. Okay, so r is equal to 6 over negative 8 minus 1, and r is equal to 6 over 5 minus 1. If I simplify these down, I'll get r is equal to negative 2 over 3, and r is equal to 3 over 2. And those are my final answers. Wow, what a journey we went on with that final question. What a time to be alive. Okay, that is it for homework video number 17, not number 7, number 17. Let me know if you have any questions. Like and subscribe.